03:45 a.m., a river crossing east of the front line. The Russian logistics officer watching the feed believes his hidden route is invisible. In 6 minutes, that belief will be wrong. By the end of this video, you'll know exactly how a temporary pontoon crossing, built specifically to dodge satellite detection, was found anyway. You'll understand why the convoy commander made the one decision that turned a bad night into a catastrophic one. And you'll see the single detail recovered from the wreckage afterward that changed how Russian engineering units camouflage river crossings for the rest of the war. This isn't the sanitized version you've read in a headline. This is the 6 minutes nobody wanted filmed. Pontoon bridges aren't supposed to matter this much. They're temporary by design. Rubber and steel pontoons lashed into a floating roadway, meant to be assembled at night, used for days, then broken down and moved before anyone official notices they existed. That's the entire point. A pontoon crossing is logistics trying to be a ghost.
This one sat roughly 11 kilometers back from contested territory, spanning a river too shallow for barges but wide enough to slow down anything on wheels. Ukrainian units had been tracking Russian resupply patterns along this stretch for weeks, not through any single dramatic intercept, but through the boring, patient work OSINT analysts actually do, counting truck shadows in satellite passes, cross-referencing fuel convoy schedules, watching for the same tire ruts reappearing on the riverbank after each rain. The Russian side knew this too. That's why the bridge wasn't semi-permanent. It was assembled after dark, used for a resupply window of 6 to 8 hours, then partially disassembled and screened under camouflage netting and cut foliage before first light. Loss tracking projects that catalog visually confirmed Russian equipment losses, the kind of open-source ledgers analysts point to for verification rather than vibes, had already recorded several logistics vehicles lost to strikes near this general sector in the preceding month. The pattern was there, the location just kept moving. Here's your first fear hook. If this bridge worked even one more night, an estimated reinforcement convoy, fuel bowsers, an ammunition truck, and at least one armored recovery vehicle needed further up the line would cross clean. If it didn't, that sector's resupply schedule would slip by days, not hours. That's the stakes, not a headline stat, an actual logistics clock ticking against actual units. Now the hope hint, Ukrainian reconnaissance drones, likely a mix of a fixed-wing scout type for wide-area search and a smaller quadcopter for close confirmation, a combination increasingly standard across the front, had reportedly narrowed the search area over multiple nights using thermal signatures off the pontoons themselves. Rubber and steel hold heat differently than the surrounding water and mud. Even hidden under netting, a bridge breathes a heat signature the naked eye can't see, but a thermal sensor can. Pattern interrupt. Let's talk about why this works. Pontoon material has a much lower thermal mass than the river around it, meaning after a hot day, it cools slower than water, but faster than dense earth. On a thermal camera, that shows up as a faint, unnatural rectangle sitting where the map says there should be nothing but current. It's not magic, it's physics the engineers can't fully camouflage away, no matter how much netting goes on top. Tension, complication, but knowing where a bridge probably is isn't the same as being able to hit it. Pontoon crossings are usually escorted, man-portable air defense teams, sometimes a mobile electronic warfare unit tasked specifically with jamming small drone control links in the immediate area. This sector reportedly had at least one such jamming asset stationed within a kilometer of the crossing point, specifically because previous, less defended pontoon routes elsewhere on the front had already been destroyed earlier in the war. The Russians had learned. The question was whether they'd learned enough. Relief insight. This is where the first countermeasure defeat happens, and it's the part most after-action summaries skip entirely. What happened next is the part most after-action reports leave out entirely. Before the strike drone even crossed into range, one radio fragment, picked up incidentally by a listening post monitoring a completely different frequency, mentioned a name, Not a code name, an actual name, muttered by a tired soldier who didn't know the channel was open. Layer 1. Jamming. The electronic warfare vehicle stationed near the crossing was doing exactly what it was built to do, flooding the local spectrum with noise designed to sever the radio link between a small attack drone and its operator. This is the countermeasure that's ended more strike attempts on this front than any physical air defense system. No signal, no control, no strike. It's unglamorous and it works. Here's your counterintuitive technical insight, the one the competitor channels never actually explain. Modern jamming doesn't need to block every frequency to be effective. It just needs to degrade the specific band the drone's control link uses long enough for the pontoon convoy to finish crossing and disperse. Jamming is a clock, not a wall, which means the attacking side's real fight isn't against the jammer directly. It's a race to either finish the strike before the jamming window closes or switch to a control method the jammer isn't tuned for, like a fiber optic tethered drone that can't be jammed at all because there's no radio link to interfere with. Fiber optic FPV drones, trailing a literal spool of thin cable behind them, had already started appearing on both sides of this front by this point in the war, precisely because of jamming duels exactly like this one. First countermeasure defeated. The operating team, reportedly using a relay drone hovering at higher altitude to extend and stabilize the control signal above the worst of the ground-level jamming, kept enough control authority to hold the strike drone on approach. It's a small win. It's not the story yet, but it's the difference between a mission that ends in a jammed drone crashing into a field and one that continues. Fear spike. Then, the second layer activated. A man-portable air defense team, positioned exactly where you'd expect, high ground with a clean sight line down the river valley, acquired a heat signature. Not the bridge this time, the drone itself. Pattern interrupt, human detail. The radio fragment mentioned earlier belonged to a junior engineering officer, the same one likely responsible for the bridge's camouflage discipline that night. In the noise of a busy resupply window, he'd used his own name instead of his call sign, just once, coordinating where the netting needed adjusting after a truck had clipped it. It's a detail that means nothing tactically. It means everything narratively. Because it's a reminder that every convoy and every story like this has a person in it who was just trying to get through a shift without anyone getting hurt. Second countermeasure defeated. The strike drone, reportedly flying an altitude profile low enough to stay under the Manpads team's ideal engagement envelope, while still high enough to avoid small arms fire from the crossing's ground security, made it through the intercept window. This is the payoff ladder moment, a genuine near failure with an actual reason it didn't fail, not just narrated tension for its own sake. This was the most dangerous 90 seconds of the entire mission, not because of the jamming, not because of the Manpads team, because of what neither side yet knew. A second Ukrainian drone, tasked purely with battle damage confirmation, was already airborne and approaching the same airspace, meaning two friendly systems were converging on one target with two separate operators who couldn't yet see each other. Specificity bomb. Publicly available loss tracking archives that catalog confirmed Russian equipment destruction by geolocated visual evidence had by this stage of the war recorded several dozen logistics and engineering vehicles lost, specifically at river crossing points across multiple front sectors, a pattern analysts had flagged repeatedly as one of the most consistently exploitable choke points in Russian resupply architecture. This crossing was about to become one more entry in that pattern, or it wasn't. That uncertainty is the entire reason anyone was still watching a screen at 3:47 in the morning. Relief insight. Deconfliction between the strike drone and the confirmation drone reportedly happened the low-tech way. A radio call between operators, altitude separation of roughly 100 meters, nothing exotic. Sometimes the most dangerous moment in a strike isn't the enemy, it's your own side's timing. Fear stakes. The strike drone was now within its terminal approach. The pontoon bridge, fully loaded with the resupply convoy mid-crossing, had perhaps 90 seconds left before it would clear to the far bank and disperse into tree cover, becoming untouchable again for days. Before the strike could land, one thing the convoy didn't know existed activated: a decoy heat source. Reportedly, a simple burning fuel drum staged nearby specifically to confuse thermal-seeking munitions. A low-cost countermeasure increasingly common on this front, and the single cheapest trick that has, in other documented cases, actually worked. It didn't work this time. The strike drone's operator, watching the same thermal feed the decoy was built to confuse, recognized the signature mismatch: a static, symmetrical heat bloom sitting apart from the bridge's own thermal shadow, rather than the messy, moving heat signature of loaded vehicles. The decoy bought maybe 10 seconds. It didn't buy the mission. The strike drone held its terminal dive on the actual crossing point, impacting the pontoon roadway directly beneath what open-source imagery and lost tracking catalogs would later suggest was the lead resupply vehicle of the convoy, consistent with the kind of fuel Bowser losses repeatedly documented at similar crossings across the war. The detonation severed the pontoon section itself, dropping a portion of the roadway into the river and, per subsequent visual confirmation typical of these strikes, disabling at least one additional vehicle further back in the queue that couldn't reverse fast enough on the narrow approach. Secondary effects: with the crossing severed, the remainder of the convoy was stranded on the near bank until a replacement pontoon section could be brought up. A delay measured in days for a resupply run that was supposed to take one night. The engineering officer whose name had leaked over an open channel earlier was, per the same radio traffic pattern analysts had been monitoring, audibly present in the aftermath coordination. Alive, according to available reporting, but now responsible for explaining to his command why the crossing his team had camouflaged so carefully had been found anyway.
Aftermath. This strike became one entry in a pattern that Russian engineering units reportedly responded to by changing crossing disciplines sector-wide. Shorter assembly windows, more frequent relocation of pontoon sections between uses, and reportedly increased use of thermal-blocking tarpaulin rather than standard camouflage netting. None of it fully solves the underlying problem. A pontoon bridge, no matter how well hidden, still has to cross water in a place the water allows it to, and that geography doesn't move even when the bridge does. The single detail that changed things going forward wasn't a new weapon. It was the recognition that decoys have to move to work, and static heat sources are a tell, not a trick. If you want to understand how something as simple as a burning fuel drum became a genuine electronic warfare-era countermeasure, and why it still sometimes fails, the next video breaks down the full history of decoy and camouflage doctrine on this front, including the one system that came closest to stopping a strike like this one before it ever launched. If tonight's breakdown gave you a clearer picture of how these crossings actually get found, there's a lot more of this kind of detail waiting in that one.